I'm Nat. I am a neurodiversity expert at an organization called Exceptional Individuals, and I support people all over the spectrum from dyslexia to autism, ADHD, dyscalculia. It's important to know what I am. I am neurodiverse, so I have dyslexia, I have dyspraxia, as well as others. I also work with neurodiverse people every single day of my life, and it's something I'm extremely passionate about. But what I'm not a neuroscientist. I am not a doctor. So while I have gone to quite large extremes to make sure everything in today's webinar is as accurate and as representational of the facts as it possibly can be, I cannot guarantee. So if there are mistakes, please just let me know in the comments and I'll happily adjust it. Okay, we've got Runa. I'm a teacher in semi-rural South Africa schools with learners have behavioral difficulties studying psychology and criminology. Very nice. And Lynn, I'm Nat. So that's Nathaniel Hawley. But you just call me Nat. Nice and short. Okay, Christine, I can see you. Victoria, nice. Nathan, Claire, brilliant, just to name a few. So Exceptional Individuals, I'm not sure if any of you have heard of it or not, but we're a UK-based company in London. We've been going about 6 years now, and we're made up of an amazing team of neurodiverse individuals. We specialize in all of neurodiversity, but we do really focus on the 4 key ones just because of how prevalent they are and how widespread. Dyslexia, though, has always been our focus, and that's because it's something that everyone in the team has, as well as something which is extremely common, roughly between 5 to 10% of the population. So a little bit more, we help recruit diverse talent. So maybe you're in a real big organization, there's not enough innovation, you've got the same mindsets time and time again. We'll help get those really innovative people into your job space. But as well as that, we make sure that they have everything they need to succeed. We are very much about strengths of dyslexia, but let's be real here, there are challenges and you want to make sure that they're acknowledged and catered for in the workplace. We do support, so maybe you're looking for job coaching, maybe you want help with your CV, or maybe it's just about confidence because, life's been difficult. Most of the time, dyslexia isn't your key challenge, it's something which exacerbates everything else that's connected. Workplace needs assessment. So if you're looking for support, if you're struggling in the workplace, we can make sure you have the right coaching, mentoring, assistive technology, and we do drop-ins and workshops. Here's a picture of our lovely team. So the science of dyslexia. The science of dyslexia is a very complex field and there's so much still unknown about it. So today I'm going to look at several different reasons, theories, explanations, things that we need to explore further, which could indicate why our brains operate the way they do. So think everything I'm saying today, there is facts, there are research to back it up, but do know that more research is needed. So why do we have dyslexia, first of all? I want to go back in time a little bit. So first of all, reading is really complex. I know some of you are like, I read every day. Trust me, for your brain to read, it takes a lot of cognitive ability. Our brains weren't built to read, and yet we've been able to allow that, teach them and make them read. The part of our brain that reads wasn't built for that originally. It is our brain has kind of freed up that space and kind of slotted it in. 8,000 years ago was the first recorded history in China. That's when we're like, okay, people are doing a bit of writing. In fairness, it was to document finances because, nothing's going to really push innovation like wanting your money. Then 4,000 years ago, the alphabet was introduced in ancient Egypt. I mean, it was introduced in other places, but please take everything I'm saying today as an extremely simplified version. And I want to simplify it because it makes it far more accessible to as many people as possible. Until last century, reading was mostly taught to religious scribes. So those who were documenting religious scripture, improving the generations, it wasn't really needed for anyone else. So even though 8,000 years is a long time, we're looking at only the last century where it was kind of standard knowledge where we were expected to read. So now, 1950s, we're getting up to modern time. Only 55% of us were literate. So that's just over half of the population, only in the 50s, which I'm sure some of you may have been born around then, could read. That is 12% of us with access to education struggle with literacy. So even those who are in like Western countries or those who have really established education systems, there's still a massive percentage who struggle to read. And why is this? Well, in short, literacy has no advantage for most of history, letting the dyslexic gene continue. A really good way to compare this is to people who are ginger. In 2050, they reckon that ginger people are going to go extinct. I know, Prince Harry, we need you to keep having babies. But genuinely, we've got a ginger crisis. And that's because selectively they are being bred to extinction. But why isn't dyslexia being bred to extinction? And that's because there's no reason to. For the vast majority of human history, reading hasn't been necessary. And there's no reason, like if you're Genghis Khan and you're, having thousands of children, you don't care if you're a lovely lady is literate. If you're, working in a farm or agriculture, you probably wouldn't care. And this is why we do not see Darwinian evolution in this sense. And there's no signs that dyslexia is going to go away. It's part of humanity. And I think it will be for a very, very long time to come. So with that out of the way, what is dyslexia? Now, this is the best, most detailed explanation I could find that I agreed with. And I'm going to read it out to you. Dyslexia is a specific learning disability that is neurobiological in origin. So straight away, controversial disability. However, I'm trying to back this up with what the science research papers are saying, even if it's not what I personally believe in. It is characterized by difficulties with accurate and or fluent words recognition and by poor spelling and decoding abilities. The difficulties typically result from a deficit in the phonological, that's, the way you sound out words, component of language, and it's often unexpected in relation to other cognitive abilities and the provisions of effective classroom instructions. Okay, that was a lot. And I appreciate it's far, far more wordy than any definition I would typically give. However, this is a very comprehensive way which covers most bases. And if any of you are interested in references, at the top of the page, I've tried to reference them where I'm able to. But I can give references by email if any of you want exact sources. This is one of the best, most visual ways I like to use to explain dyslexia. As you can see, you can hopefully read this. Dyslexia is characterized by difficulties with reading, with learning and to read fluently with other accurate comprehension. It's very much readable, but it's challenging. And that's because our brain is unable to process it and work things out. And for a lot of people, we read words phonologically, just breaking them down. But with dyslexia, your brain doesn't like doing that. So it might read an image by kind of flattening it. So cat is cat because you remember the way it is written. And this is one way which I find works fairly well when it comes to explaining dyslexia. A quick 101. What percentage of the pop is thought to be dyslexic? I have actually already mentioned this today. So is it 5 to 12%? Is it nothing? Or is it option 3? Wow, you can tell I had a late night last night. Awkward. It'll be fine. Wow. Okay, 2 of you picked option 3. Come on. That's on you. It is about 5 to 12%. It varies. And also the way we diagnose it or recognize it is very different depending in countries. It's higher in England because of the English language, the way it is written and spelled compared to other countries like Germany or China or Japan, which I find is very, very interesting. Okay, question 2 of 3, which hopefully will be more successful than the last one. Dyslexia involves difficulty with reading, writing, or speaking. What is the difficulty that is associated with reading? Brilliant. Well, it is actually all of them. And I think a lot of the time we refer to dyslexia as a reading condition or disorder, but it actually affects a lot more than that. It affects how the brain processes information. And hopefully, by the end of the day, you'll understand why it affects those different areas. But yes, reading is what people typically think of. And I can see a lot of you put that as well. Okay, last one. Is there a correlation? So is there like a link between intelligence and dyslexia? And remember, we're coming at this from a scientific perspective, not a personal opinion. No, it is no. And yes, you can have a lower average intelligence and have dyslexia. Of course you can. But those two are not linked. They're separate. Dyslexia is typically diagnosed from a high ability in other areas, maybe IQ, processing, speech, but a deficit in another area. So those highs and lows do not kind of add up. So there is zero evidence to suggest that intelligence is affected by dyslexia. Okay, let's see who's winning. Well done, Amy. I kind of wanted Tiger Baby to get there. I like the name, Simba. But yeah, Amy, well done. What a pro. So now we're getting into the juicy stuff. This is where we get in hard and heavy on the dyslexia brain. So Kira says, I thought dyslexia meant you were smarter. No, not necessarily. You can be smarter in other areas, but there's no link to say you're smarter or dumber. You're just you. So let's see, what are the difference between a dyslexic brain and a non-dyslexic brain? So here's a lovely picture of the brain. The brain is split up into your right side and your left side. And simplifying it, one side is more about reading and writing and language, and that's the left side. So as you can see here, we've got lots of squishy bits, and you do not really need to know what any of that means, but know that a lot around dyslexia comes from this kind of like middle section. And in our brain, we have matter. We have white matter and gray matter. And all matter is, it's your brain kind of like the different kind of areas. Now, interestingly, as some of you may have noticed, yes, the white matter is the inner layer. Is it white? Not really, but when you dye it, it goes a bit more of a whiter color. And when you dye the outer area, it goes a bit darker. They just needed a way to like differentiate it. But actually, interestingly, if you go down your spine, that part, the white matter is on the outside and the gray matter is on the inside. So it's quite interesting. And science has been able to do a lot of studies through like MRI scans, and they found out people with dyslexia typically have less white matter. Why? Well, we'll get into that. But they also have less gray matter, but white matter is the matter that we're going to be mattering about. So changes in the brain. So as I said, we've got the, and please excuse my pronunciation, the temporal and the perennial, like this middle section here, is typically where we notice the changes in the brain. Dyslexics have been found to have less gray matter in the left parietal temporal area than non-dyslexic individuals. And they've done this study a lot over the place, and there's less matter, and that's relate. So does the amount of gray matter in your brain equal dyslexia? Yes, but that doesn't really explain why we're dyslexic. This is something which shows like, okay, they're struggling to read, dyslexic. They have less gray matter, dyslexic. That's not a good enough answer. So though this is interesting to know that your brain has slightly less of something, it's not a good enough answer. And normally when we say less of, you might think, oh, okay, that's a disability because you're missing out on something. But the brain typically compensates, and then there'll be more of another matter. So do not think you're getting a bit of a raw deal here. You're just getting more of something else. Okay, so now we're looking about the dyslexic gene. So in our grey and white matter, there's genomes, and your genomes are just essentially your DNA. So what makes you you? You got your mother, your father, the DNA comes together and it makes you. Think of DNA like an instruction book. Okay, yep. So we're gonna need some blue eyes. Do you have any blue eyes? Brilliant. Blonde hair, great stuff. Diabetes, screw it. We'll give you diabetes. All right, Nathaniel, here you go. That's what DNA is. And DNA does determine whether or not you're dyslexic. And so, okay, we're getting a little bit further. We know dyslexia is to do with reading and speak and writing. We know dyslexia is about the amount of grey matter you have in your brain. We know that dyslexia it has its own gene within the grey matter. But how about we go a little bit deeper? You know, we're getting meta today. We're going like subatomic. We're like Ant-Man today. So as mentioned, it's part of your genes. And this is related because dyslexia is hereditary. It runs in the family. And they found this out by doing like twin studies. And for a while ago, they thought it was like nature versus nurture, and like it was more the nurture side. But no, it runs in the family. And you can actually skip a generation. So maybe your grandmother has dyslexia, your mother doesn't have dyslexia, and you do have dyslexia. One of you has put a tree. I'm guessing that means your children, hopefully. And so even though you may only be aware of yourself or your children, that doesn't mean that other people in your family weren't dyslexic. Dyslexia isn't something that just came out of recent time. It's always been there. It just hasn't been an issue because our culture and society has placed less emphasis on reading and writing. So now we've got this lovely famous image of evolution. FYI, this isn't actually how evolution works completely, but it's a fun image. So despite dyslexia being hereditary, there's not much evolutionary selective advantage to being able to read well. This is what we explained right at the beginning. So as you can see, let's say this little fella had dyslexia. This one would have no reason not to be dyslexic. Doesn't affect him, doesn't affect him, doesn't affect him, doesn't affect him. Okay, now we're getting to modern time. And this is when being dyslexic is a evolutionary disadvantage in early established culture. But we have created technology, assistive technology, coping mechanism, inclusive employers, and they are getting more and more and more. So the time in history where dyslexia was a disadvantage is really, 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 really small. And as a result, evolution is not bothered. It needs to be a much, much larger time for anything to kind of get weeded out. So do not expect dyslexia to go away anytime soon. There's no reason for it to go away. Now we've talked about your DNA. Let's go a little bit deeper. What is DNA? DNA is your genetic makeup. It's what makes you you. Now, in your DNA, there's all different genes, and they're kind of like packaged up as little like package deals. And there's been 3 genes which have been found to correlate with dyslexia. So you've got the DYX1C1 standard gene. You've got the DCDC2, which is an interesting gene. That's also closely related to people who are deaf. So it's interesting that we share the same gene. And then we've got the KIAA0319. You do not need all of them, to be dyslexic, sometimes just one or the other, but those ones together always seem to relate to those with dyslexia. The names are going to be confusing, but I'm going to go through them one by one and explain why each of these genes equals dyslexia. And you'll know, and you might be able to work out which one relates to you or the people you support. Ultimately, the results are very similar. So if we zoom out a bit when it comes to what you're actually struggling with in real life, it's very similar. But if you zoom in, there is a difference. And there's been lots of studies on this. So lots of research. Do check out, see again, references up there if you ever want to dig a bit deeper. But as you can see here, they do notice a difference. So, okay, we've got less gray matter here. Cool. Let's look in the DNA. Brilliant. Okay, in the genomes. Okay, in the genomes, we've got these genes. So as you can tell, the closer we get, the more information we are getting and the more consistent differences we are observing. Okay, no parking. Why did I put it up there? It's a spelling mistake. And the next thing is a study found a single neurolotide polymorphism. Oh God, please forgive me. I'm dyslexic. I think that's like the only time I can use that excuse. I promise you I don't use that excuse normally. But we're going to call him an SNP. No, we're not talking about the Scottish Nationalist Party. Sorry, Nicola Sturgeon. We're talking about the pin blocks. So in your DNA, which your DNA, there's little markers. And these markers are what you're able to pick up on when you examine DNA. And think of these markers are in between the DNA. So when, like, let's say that's a DNA, and that's a DNA, the SNP is the thing in between. And that allows you to like pick up and like find it and sort it out. So you can think of SNP as a significant one-letter typo. Imagine you've got your Word document, all reads well, completely makes sense, and there's a typo. But not a big typo, one tiny typo. Maybe instead of putting the word letter I, you put the letter 0, and you're like, no, it doesn't make sense. And the brain can kind of, you can guess it. You're like, one mistake, whatever, move on. But take, for example, your boss is doing your paycheck, and by accident, he makes a typo, and there's 1 0 missing at the end of your paycheck. Suddenly, that one little typo is kind of a big deal, and that you're not going to be happy. So that's what you should think of. Within your DNA, you've got SNPs, and they're just tiny little typos. Is that a bad thing? Not at all. Mutations are normal. For instance, if you have lots and lots of mutations, it could be something like cancer. Ew, not great. But little mutations help spearhead innovation in terms of the human body. The reason we were able to walk, the reason we were able to breathe oxygen, every little adaptation the human brain has ever done has happened through tiny, tiny little mutations. And if those mutations go across the generations, and if they've actually helped the person, they continue. Or if they are neutral. So if they're negative, they'll be taken out. But if they're, doesn't do much, there's no reason why they would leave. And that's dyslexia. So think of it, it's just a tiny little difference in the body, which has actually, butterfly effect, got bigger and bigger. Now we're getting somewhere good. So we've talked about little mutations, we've talked about your DNA, and how does this relate to dyslexia? Now, I don't know if many of you know, but in your DNA, you go a little bit deeper and you've got your neurons. Your neurons are think of them like your copper wiring, your phone lines, your internet cable. These are the wires that go from your brain, go, and they're like telling everything to do everything. So they're busy little bees. And what science used to believe is that what you're born with, you're born with. They stay in one place. You've got a neuron there, they stay there. But that's not true. In your first 6 weeks of being born, they're moving a lot. And even in the first 3 months of being born, they're moving around. So as you can see here, this is an actual neuron moving along. You're like, going through your body, connecting things up. And this is where gray matter and white matter is created. It's neurons sending information, building it up, expanding it. So think of this like a neuron travels from their birthplace to their final position in the brain. So neuromigration is just the signals in your head moving around. Another way to think about it, okay, so you've got your internet box is in the store. It's sending information around. It's doing the job it was created for, but it's not going to stay at the internet shop. You're going to take it and you're going to bring it home. And that's where it stays. So yes, it will stay in your house forevermore, but originally it was at the store. So neurons do move in early life until they reach the place they're happy with. So neuromigration, think of this. Like another great analogy is, was it Moses when he's like separating the sea? The sea is, it's not an easy journey. It takes a very special neuron not to kind of travel across the depths of your brain. And a lot of neurons sadly aren't going to make it. Some are going to be swept away. Some will kind of like fall in on themselves. We're going to lose a couple of stragglers. It's not an easy journey. And this is why when you kind of bang your head, or like, you know, that's called acquired dyslexia, you know, your neurons can take a bit of a punch. Now with dyslexia, conventional dyslexia, which we're familiar with, it's these little dyslexic genes are getting in the way, and they're like, you what, mate? Come on, neurons. And they get rid of them. So this is why if these neurons aren't going to where they want to go, we're going to have a bit of an issue here, because they're trying to travel up their ocean like Moses does, and suddenly they're not actually getting to where they need to get to. Now we're finally understanding why dyslexia is dyslexia. I'm going to explain this a little bit fuller because I really think this is very crucial. Until now, we've explained what people with dyslexia have in common, but we've not explained why. So we've got some lovely babies here. Think of a neuron as a little baby. Oh, little neuron. And it's having a great time. So it's like a baby neuron leaving the maternity ward and going home. So like the internet analogy, it's the same one. The baby was born in one space and it's going to go to a new space. And everyone does it. It's very, very normal. And it should be a nice, straightforward thing. And this is exactly like dyslexia. So imagine this, you got your baby and then you're on the way home driving. You look at the back of the car, my baby, where's my baby? you lost your baby. And yeah, that's extreme, but that's what happens in the brain. The neurons that have to get somewhere do not get there. And this is why dyslexia is for life. It happens early on before you're even born, but it firmly cements itself within like 3 months of you being born. There's nothing you can do about it, okay? This isn't anything you've done wrong, your parents done wrong. This is, it's those little genos, those SNPs that are kind of stopping it and confusing it. Brunner has said, in my study about cognitive sensitivity, sometimes you can rearrange some information and make people read again. If you can, probably you could improve the size of the amygdala. That's a little bit here. And reuse this as a support to read. But if you can, somehow your brain has connectivity issues. If not done research, but this is part of my results. Interesting that you're doing further results. I think there's a lot of research going on, and it's something which is consistently changing. What I'm doing today is the most accepted research, but it's by no means a finished article. So as you mentioned, we've got these little neurons. They've got to go home. They're getting a little bit lost. Oh no, neuron, we've lost you. I'm going to read this out now, and this is a bit heavier, and normally I like to keep things a bit lighter, but it is important, and there's only some things you can explain using funny little GIFs. So the DCDC2 gene, which we mentioned originally, this is the one we're focusing on, is likely linked with the proteins involved in creating cell polarity. So when your kind of cells are all busy creating, there's a gene which kind of stops it. So imagine it's not getting the food it needs to grow. It's a little bit stunted. The protein, hate you protein, interferes with the shape and size of the cell, while neurons develop. So again, you're doing your neuromigration, and if one of these little cells has like an injured leg, it's going to be not getting to where it needs to get to as fast as it would like to. So it's been hindered in some way. Cell polarity has a big impact on neural migration. As a result, typos, so those little markers, those one-letter typos on the DCDC2, what a mouthful, gene has a poor migration during development. So now we're explaining, great. We understand that when our brain is growing, the neurons need to get somewhere, but they're not getting to where they want to get to because the gene is stopping it from happening. So when we say this gene relates to dyslexia, now we actually understand why. It's an annoying little gene which stops your neuron getting to where it needs to get to, as a result, leading to lower white and gray matter. As a result, impaired neuromigration means that not every neuron leaves the maternity ward. So sometimes they never leave at all, they stay put. Other times, they at least get out of the maternity ward, but they never actually make it home. So there's different ways and reasons of how far that neuron's able to make it. This explains limited white and grey matter in the left hemisphere. So I hope that makes sense. I really do know that this isn't the easiest subject, so I'm trying to make it as easy as possible. But if you want me to go a little bit deeper, just let me know and I'll do my best. So this was the first gene we mentioned, right? And this is the most common reason why dyslexia is probably so prevalent in our society. However, we mentioned 2 more genes. Now we're going to go to the other genes. This one is the gender imbalance in dyslexia. So is dyslexia more common in males and females? First of all, more males have dyslexia than females. Yes, the research says that, but that's because of the way it demonstrates itself is different. And when we diagnose people, it's through an assessment that was created by white males who probably aren't dyslexic. So do take that in consideration. The next thing is that women are more likely to be dyslexic according to science because of an extra gene, and that's more likely. I'll explain a little bit more about that in a minute. Regina says, but why does it only affect the left and not also the right? That's a really good question, and I do not know that, but I would imagine it's because that's the part of the brain which those kind of little SNPs, those little defects, are like latching onto. I guess we all have a preference, and that's the preference that they want to go for. But also, it does affect other areas, but that's the area that affects dyslexia. So as I mentioned, you know, the second gene, which we're talking about now, that affects people who are like deaf or aren't able to hear. So it does affect other areas of the brain, but those other area brains aren't responsible for reading, writing, comprehension. So that's the main reason. Holly says, interesting, since so many hereditary disturbances affect males more. Yes, no, this is one of the interesting ones. So here, dyslexia impacts males and females alike, right? Kinda. The dyslexic gene sometimes have a small error. We know this, we spoke about this, that tiny little typo. The error is one of the typos that code for dyslexia. When the typo is inherited, it comes with another dyslexic encoding typo. So think about this, you've got a typo within a typo, and then you kind of get like multiple that build up. Now you've got 2 tiny errors. This is only in females. So males will have 1 error, females will have 2 errors, and 2 errors increases the prevalence and likelihood of dyslexia. With both typos present, estrogen's pathway gets damaged. So, you know, lovely estrogen, which is an abundance in females. Now we've got 2 tiny errors, like being at a nightclub saying no entry. And it makes it twice as difficult for these neurons to do their migration and get to where they want to get to. Usually estrogen receptors bind to a protein. So we spoke about these proteins, essentially for brain development. So while dyslexia is prevalent in males and females evenly, females might get impaired estrogen receptors. So the things that kind of join together are no longer able to join. It's like, have you ever, like, you know, when you got sellotape and it kind of sticks to everything, but if you try sticking sellotape to your teeth, it doesn't stick. And that's because like the coating on your teeth is kind of like that. And it creates like a coating where they're just not able to join or get past hormones. But dyslexia is more connected with recognized shapes. It can replace other senses if possible, but not guaranteed. Yeah. And now on for the last gene that we mentioned. So this is the last reason which is believed to affect dyslexia. And we're doing really good. Dyslexia and autoimmune disease. So believe it or not, those allergies, or, you know, it's no coincidence. There is a correlation between weaker immune systems and diseases. So I just want to ask any of you, if you are dyslexic or know someone, like, do you have arthritis? Do you have lupus? Do you have allergies or any other autoimmune diseases? You may have noticed I've not used any little GIFs for lupus. You know, couldn't find one. Couldn't find any GIFs for it. Anna says allergies. Yeah, I have extreme hay fever. And you might just think, well, that's just a coincidence. But no, there is a link. There is a strong link between allergies. It's autoimmune disorders and diseases. It's when your body attacks you. It's like, whoa, 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 this, you shouldn't be here. And it attacks you, even though it shouldn't be. So when pollen goes up my nose, I'm sneezing because my body's telling it, like, we should get that out of you. But I'm all like, it's only a bit of pollen. It doesn't bother me, but my brain's not listening. So there is a link. Histamine intolerance. Yes. Colline disease. Brilliant. Oh, okay. I can see we've got a lot of allergies in the group. And this is where it comes to the last one. So the KIAA0319. Let's call him Gary for short. So 15% of dyslexics recorded severe autoimmune diseases. That's really interesting. Such a high percentage when you think about it. That's about 30 to 40% more likely than the rest of the population. Who would have thought that when you were a kid back in the class, you know, struggling with your English homework, and you would have never guessed that that also strongly relates to allergies. But it does. The science backs it up. So while one of you mentioned, well, why doesn't it affect the other hemisphere? Remember, these genes or these little errors, they do affect the rest of your body, but you might not notice it. Sometimes they go unnoticed, other times they affect other areas. So the Gary gene is in DNA called HLA complex. HLA gives rise to the immune system. So your immune system, and inside it, you've got your DNA, and inside your DNA, you've got your gene. Just like in dyslexia, where it's like, you know, it's like Inception. You can go further and further. The same gene can have multiple implications. The Gary gene houses a typo that interferes with the HLA complex. This one little error can cause immune system problems. So hopefully you're starting to understand now. It doesn't matter what gene you have, whether it's the most common one, whether it's the one that relates more to females, or whether it's this one. It's a tiny little error. But I do not want you to go away thinking, oh, I'm full of errors. No, errors are good things. Little mutations are what made us evolve and be who we are today. So they do not have to be an inherently bad thing. A lot of the time, they can be a massive advantage. Some work, some do not work. It's kind of like the body's trial and error method. So Rena says, does anyone know an easy at-home method to test dyslexia? I recommend going on Exceptional Individuals website. We have like a characteristics quiz, not like an official GP diagnosis, but it's a good starting point. Visual Magnocellular system. So this is about the eye. And I'm sure some of you have been wondering, okay, I'm understanding now. Hopefully you're starting to understand why you are dyslexic, but that doesn't explain why you struggle reading. Okay, I get it. I've got a dyslexic gene and it's an error in my body. But why am I struggling to read? It doesn't make sense. What's the relation? Well, let's get into it. So visual Magnocellular system. And I apologize for all the writing on this one, but this was, again, quite complex to simplify. A part of the eye responds for timing individual events while reading. So you're reading along and the brain knows exactly, like, it's split into time increments. It has M cells. So M cells, I'm going to use that a lot, all right? So remember M cells. M cells, which are to 50 times the size of other eye cells. So they're very easy, well, fairly easy to find in the eye. They're a much, much bigger cell. The M cell responds to rapid changes, these receptors to temporal changes. So remember, you're moving around, you're on a roller coaster, you're looking left and right. If you think about it, you know, that you see the blur, that's really difficult for the camera to focus in on. And your eyes have to do the same thing. It has to focus even if you're moving around. So the M cells are able to respond to those rapid changes. Non-dyslexics do not notice movement because the retinal system suppress that signal. So while your non-dyslexics are reading, it's completely fine to you because as you move, the M cells kind of track the words and keep it all steady. A good M cell system is vital to keep our visual world stationary and reading. So if you do not struggle with reading or kind of keeping track or motion, you've probably got really good quality M cells. Poor neuromigration, remember our little buddies at the maternity ward getting to their final destination, in dyslexics during brain development also impact the system. So because our neurons aren't able to get to where they want to get to, this can result in poorer or less developed M cells. As the neurons don't position correctly, M cells end up in incorrect layers. This reduces M cell sensitivity and therefore blurring of words. Does this start to make sense? I'm hoping it's making as much sense to you as it is for me now. We struggle with reading because we're not able to focus on the words, because we have M cells that weren't correctly developed, because our neuromigration wasn't successful, because our genes had little tiny errors in them. And that's because of like genetic mutations. So we have a really clear explanation now to why dyslexia is a thing, what it does in our body, and how it results in. So you can read this. Just remember, when you're reading, even if you're dyslexic, just remember how amazing that is. It is, for us to learn to read, we have gone beyond biology and humanity. You know, we've gone beyond evolution. We created reading. Our bodies weren't designed for reading. It's only in very, very, very recent history where we have started to read. We have reprogrammed our brain. And there's a lot of us where the brains, you know, we are fighting. We are a fish swimming upriver. It's not easy, but it is possible. So when you're struggling with reading, just remember, like, the fact that you can read as much as you can do is an astonishing accomplishment in such a short amount of time of human evolution. What I would say, if any of you have found out, like, you know what, cool, Nat, but I am dyslexic and I need real world help, you can get in touch with us and we can do workplace needs assessment. All you need is a job. We do a quick assessment, only takes an hour. We find out what works for you, what doesn't work for you. We apply for a grant if you're in the UK. If you're not, it has to be private. And then we deliver a training. All I would say is get in touch with us, but it's definitely something worth exploring. Do any of you have any questions? And I will do my absolute best to answer them if I'm able to. So Megan says, what about dyslexia in other languages? Really good question. So there's been reports that dyslexia is less prevalent in other communities, such as like China, in Chinese, because of the way that we pronounce the words. So the hindrance is less severe. So whether it's because of how diagnosing people is more common in countries with more difficult languages like English, or whether it's because there is a link. But it does look like dyslexia affects across languages more some than others. So for instance, in Italian, it affects it less than in English. I think a lot of research really still needs to be done in this area, so I can't say convincingly, but it definitely looks like languages that are more phonological. So, you know, like English is a very complex language because when you've got to know the word, you can't just understand the structure because we have like lots of like silent E's and stuff. So it does affect it. Does your company exist in Australia? Kira, unfortunately, no, but that doesn't mean we can't work with you. So all our key face-to-face services are in the UK, but we do work internationally. We work a lot in the US. Currently, we haven't worked in Australia, but that's not to say we wouldn't. About the colored glasses, yes. So colored glasses, that is just changing the contrast between words. So that goes to the last one we mentioned about the brain kind of focusing. And different contrast, like white and black, is quite severe. So by changing the colors, it can allow the brain finding it a bit more comforting and soothing experience. So like lock onto those words. No question, but I found this to be an amazing session. Thank you so much. No, I'm really glad. And we've got, is there any differences in the presentation of dyslexic brains, male and female? That's a really good question, and I can't give you a good answer for that. There definitely is a difference when it comes to the second gene that we mentioned, but when it comes to the other genes, like the first and the third one, I haven't read anything which would indicate any differences. So yes and no, but mostly no. How common is comorbidity between ADHD and dyslexia? Incredibly common. I believe it's something like if you have one, you're twice as likely than the rest of the population to have an additional one. So think of neurodiversity like a big spectrum, and we're all on the spectrum. So it's not so much like, okay, they're separate things altogether. A lot of the time, the proteins or like the genes which establish dyslexia are often the exact same ones for ADHD, but they might be slightly different because remember, mutations, they're all different. So it's more like characteristics rather than completely separate things. Amy says, for sitting timed examinations, how much extra time do you think should be a reasonable level for the playing field? Oh, that's a really good question. Is the 25% is the average time given in the UK. Whether or not that's enough, I can't say. I think it's a very individual basis, but I would say 25% is like the average. Whether or not that's enough time, it's not for me to say, but that's what most people use. Thanks so much, Nat. You're the best. Oh, you can come again. What other areas of the brain and the function presentations are affected? Victoria, I'd love to answer that, but that's a whole nother presentation. But it does affect other areas. Thank you. Now I have a better understanding of why a person demonstrates dyslexic characteristics. Is it possible to overcome dyslexia by practice? Good question. No. Yes. Maybe. Dyslexia is for life. Once your little neurons have made their path, they've made their bed. But what you can do is learn coping mechanisms and strategies to work with your brain and not against your brain. And a lot of people with dyslexia do a thing called masking, where they kind of like cover up the symptoms, but it's still very much there. So it can get easier the older you get, but it doesn't necessarily change in terms of your brain. But if you are doing things more and more, like reading, even if it's difficult, the neuro pathways which to communicate get stronger. Think of it like working out and getting really muscly. The more you do it, the better you get. So you can't get rid of dyslexia, but you can make those connections extra strong and can help improve it. But I really hope you enjoy today. This session has been far more scientific and academic than any session we've ever done before. So if you have enjoyed it, do let us know. If you have feedback, I would love to hear from you. But I've really enjoyed researching it and hearing from all your opinions. But please use today as a starting point, and hopefully it's increased your understanding enough to make sense of this kind of crazy world we find ourselves in. I'm going to go now and have a break because my brain's burnt out. I don't know about yours, but I think it's been a really interesting journey. Cool. Bye, everyone.